So welcome students for this foundation class, and we have some SEEP students from Kerala, we have foundation students from Tamil Nadu, and we have some students from Maharashtra also. So it's nice that we have our science teacher, Madam Sneha. She is joining us from Baroda. Baroda is in Gujarat, you all know, and she is a teacher in a school. And very importantly, she was my teacher. That's very important. She was my teacher for some other subject some time back, maybe about a year and a half back. So we know each other for about 1 year. So I think now the floor is hers. Madam, you can start, madam.
Hello, good evening, everyone. So, as sir said, this is Sneha Shah, and I'll be taking up your science sessions for now. And I hope you all enjoy learning with me. To begin the session, first of all, for me as a teacher, as a learner myself, first thing is the learning process is a lifelong process, right? So what I understand about learning is I never say studying, I never say, learning by heart. I say understanding, I say learning. So you learn something new, you understand something new that is going to help you in future. So what I mean by saying this is, as foundation students, as students of 9th and 10th classes, first question you should have is why we are learning this, right? So whenever you start a topic, whenever you learn something new, always have the question why. So today I'll be sharing my topic that we are going to cover today is the structure of an must not a very new topic to all of you. To some of you, you might have learned it already. We will be beginning with this topic that is the structure of an atom. So my question would be, anyone is free to answer. Why you should learn the structure of an atom? First of all, I hope you know what an atom is. If you don't, anyone is free to answer that what an atom is, and then let me know why you need to learn the structure of the atom. Anyone? Yes, Kavinaya, please go ahead.
Yes, ma'am. Atom is a very tiny particle. They are indivisible particles, ma'am. It is said by Dalton.
Okay. So why do you think it is important to learn?
Ma'am, your voice is not clear, ma'am. All the particles in the universe are made up of matter, and the matter is made up of atoms, ma'am.
Sneha, madam, your voice is breaking
That's
little
right.
bit. Your voice is breaking. Maybe you can come closer to the mic, I think.
Sir, am I clear now?
Yeah. It's clear. It's clear. Better.
Okay. Yeah, okay. So we were discussing why it is important to understand the structure of an atom. Kavinaya, you were saying something.
Yeah, yes, ma'am. They are the basic building blocks of matter, ma'am. All the things are made up of matter in the universe, ma'am.
Okay, so it's true that atom is a basic particle of any matter, and the entire universe is made up of atoms. But why do we need to understand the structure, what is inside the atom? We have the objects, we have the things, we have the matter. We know that this exists in the form of an atom. Then why do we need to understand the structure? Yes, someone is raising the hand. Please unmute yourself and let me know. Miss Riya, right?
Miss Riya, you want to talk? You can speak.
Yeah,
Sometimes
she
you,
has raised the hand.
sometimes by mistake they will touch the button.
Okay.
Yeah.
Okay.
Yeah,
Okay.
yeah.
Okay.
Go ahead, madam. Yeah.
So, to answer this question, why you need to understand the structure of an atom is about chemical bonding. Okay, anything that you see around yourself in terms of matter, it is some or other form of a chemical compound. There are elements, you know these basics, right? There are elements, there are compounds, there are mixtures. All the compounds are made up of two or more elements. Elements are made up of atoms. Now, the structure of an atom. What is the structure of an atom? Kavinaya just said that atom is an indivisible particle. But again, there are some subatomic particles that exist inside the atom,
Yeah, yes, ma'am.
which decide how and when there will be a chemical reaction that will be taking place, and it will give a shape to new compounds. Like we have as you go in the history of discovery of various compounds, there are unlimited still unknown compounds which are not yet discovered by the scientists, by the chemists. Why so? Because we still are there to understand what this compound is made up of. Okay, we are still going, and new compounds are coming and coming every in every some period of time. Why this is happening? Because everyone is trying to understand the structure, the atomic structure of that particular compound. When you understand the atomic structure, how the subatomic particles are arranged in an atom, how they are making the bonds, then and then only you will be able to create new compounds. The already existing compounds are also made up of such arrangements. To understand their quality, to understand their characters, to understand their usefulness, you need to understand the structure of the atom. So, just by saying that all the matter is made up of atoms, and that is the reason why we need to understand atoms, is not appropriate to justify your reading, justify your learning. Always have a question: what will be the practical application of what I am learning right now? Now we are going to learn structure of an atom. I have seen multiple, there are forwards, there are jokes. Okay, we have been studying sine theta and cos theta. I hope you've come across that particular topic also, trigonometry in mathematics. There are jokes that there is no application of such things in practical life. But those people are unaware that these things are applied in the field of construction, in the field of architecture, in the field of forensics also. When you go and research on it, all these things, all these minute things are practically applicable each and everywhere. Yes, the fields might differ. You may not opt for that particular field in your future, but some or the other person will definitely use that particular topic in their practical field. So, the reason why I am discussing this is, never think that whatever you are learning right now is going to be useless. It will be useful to you in some or the other way. So, to begin with today's session, we will be understanding the basic structure of an atom in two parts. Today's part will be about how the subatomic particles were discovered, what kind of experiments were taken up by various scientists to discover those atoms, and how they came up with different atomic models. Okay, this is possible, this is possible, this is what the structure of an atom would look like, because nothing was pre-decided, right? The scientists have gone through multiple stages to discover the actual structure of the atom. Okay, so I'll be presenting my PPT right now. Give me a moment. Is the screen visible? Sir, could you please
Yes,
answer?
ma'am.
Okay.
Yes, madam.
Yes, ma'am.
Okay. So let's begin with structure of an atom. This is the part one where we will be understanding only about the discovery of various particles and how the experiments were taken up by various scientists to finally give out a specific structure of the atom. There were three major scientists. There are multiple. There are scientists who have taken up various tasks. Okay, but there are multiple people who have contributed to such discoveries. And in this one, we will be learning about three major scientists. One is Thomson, J.J. Thomson. Another is Ernest Rutherford, and last one is Neil Bohr. They have given their valued contribution in discovering various subatomic particles. Um, how do we know that there are charges? There are charges in the universe. Charges means positive, negative, electric charges. Why do we know that they exist? We know about static electricity, right? What is static electricity? When you rub two objects together, you can make the current flow through those objects. How does the current flow? By the motion of electrons. That means there are some particles that conduct the negative charge, that is the electrons. So we know that atom is divisible and it contains charged particles. Atom itself is actually indivisible. You cannot break the atom, but it's not like there is nothing inside the atom. There are subatomic particles. Why are we studying this? Objectives of today's session are to understand the discovery of atomic particles and to know how these particles exist in an atom and understand how chemical bonds are generated. Chemical bonds topic will be captured in the next part. When we talk about discovery of atomic particles, or we can say subatomic particles, there are basically three subatomic particles that we know of: protons, electrons, and neutrons. Here we have the scientists who worked on some experiments, and they came up with the fact that, okay, atom contains a proton, atom contains electrons, atom contains neutrons. So first one is E. Goldstein. He said in 1886 that, okay, before going into this, let me tell you something, that every atom, every particle will radiate some rays. Rays will be of various types. Here he discovered that there is a radiation from a gas, from a discharge of a gas, and he discovered that these radiations were positively charged. He came up with that conclusion by using the concepts of static electricity. So he said that these charges, these radiations were positively charged. And he at that time called these charges canal rays. But later on, after the discovery of electrons, these particles, these positively charged particles, were called protons. All right. So in 1900, after 14 years of discovery of the protons, in 1900, electrons were discovered by J.J. Thomson. He carried on a cathode ray tube experiment. I hope you must be aware of what that experiment is. If not, you can definitely refer to your material and you can go through the entire experiment, how he came up with that. And he discovered the electron. And finally, neutron was discovered in 1932, that there was another particle which contributed to the mass of the atom, because we know that the mass of electron is almost negligible as compared to the mass of proton, while neutrons is like it has equal mass to that of a proton. So the mass of the atom is solely dependent on the number of protons and the number of neutrons in that, and not the electrons. So there was a conclusion that there is a particle which contributes to the mass of the atom, and that particle was neutrally charged. If it had any charge, what would have happened if it had any charge? Can anyone answer that? Anyone? Am I audible? Am I not audible?
You are
Teacher,
audible.
can you repeat the question once?
I am
Voice.
simply saying that neutron was discovered that it does not have any charge, any electric charge. But my question is, what would have happened if neutron had any negative or positive charge?
Then atom may not be stable.
Exactly. Because we know that proton and electrons have equal and opposite charges, and they balance out their charges, and the atom as a whole becomes stable, becomes neutral. So if neutron had any charge, then the atom would have never been able to balance the charges, and that is why neutron particle was discovered as a neutral particle. There is no charge on the neutron. So it was named neutron as it was electrically neutral. Now, after the discovery of such particles, there was a series of experiments taken up by various scientists to understand how these particles are actually arranged in the atom. Neutron was very later discovered in the history. It was in 1932. Before that, only the structure of proton and electron was understood, and their arrangement in the atom was understood. Okay. So first scientist that gave about the arrangement was J.J. Thomson. His theory was it was simply theory. It was based on certain small less effective less effective experiments. He simply said that atom must be like a Christmas pudding, like a cake, like a watermelon. What he meant by that was, he said that the entire watermelon, the edible part, the red part, is your positive charge, and the seeds of the watermelon are your negative charge. So he said that the atom is a sphere completely made of positively charged particles, that is protons, and the electrons are studded in that particular positive charge. So that means that the electrons are uniformly divided inside the atom, and the protons itself are also uniformly divided among the in the entire atom. So this was J.J. Thomson's atomic model. First, he said that the electrons existed in a sphere of positive charge, like dry fruits in a spherical Christmas pudding. Similar concept he gave about watermelon also. Like in a watermelon, the positive charge is spread all over, like the red edible part, while the electrons are the seeds. And what he proposed was one and two things. First thing, an atom consists of a positively charged sphere and the electrons are embedded in it. The basic, his arrangement was very simple. Entire sphere is positively charged and the electrons, that is the negative charges, spread across the positive charge. And the second thing what he said was that the negative and the positive charges were equal and opposite in magnitude. Means equal in magnitude and opposite in charge. So that is why the atom as a whole was electrically neutral. So this was second point was absolutely true for right now also. The second point that he said is absolutely true, that the electrons and our protons are equal in magnitude and have opposite charges, so the atom is electrically neutral. To prove his first arrangement, to prove his first point, there was another scientist who took over an experiment. What he did was he wanted to understand how the atoms, how the protons are arranged in the atom, correct? What he did was he chose alpha particles. Now, what are alpha particles? Alpha particles are basically the particles that radiate out of helium atom. Helium is an as you know, it is an inert gas. It is a radiating gas, so it gives out radiations which are highly with a very heavy mass, and they move with high energy. So his thought process was, while he chose alpha particles, his thought process was that these radiations are very heavy. Okay, the alpha particles he chose, they were very heavy in mass and they were moving with high energy. So what he thought was, when these alpha particles will hit an atom, they will collide with the heavy proton particle and they will bounce back. Understand this by a very, very basic example. You are driving or you are riding your bicycle with a very less speed, okay? And you come across an objection, you stumble upon some obstacle. So will it hurt you more? No, because your speed was very less. So your motion, your deflection, or your bouncing back from that obstacle would be very, very less. So this is one of the reasons why he chose alpha particles, because he wanted to have particles in extremely high speed. If you are driving at a very high speed and you collide somewhere, then the damage would be much more. Your coming back, your rebound would be much greater as compared to when you are driving at a slow speed. So he chose alpha particles because they were traveling at a very high speed. So when they touch the proton, when they collide with the proton or the positive charge, they will immediately rebound. And he will understand that this is the place where there is the presence of proton. So Ernest Rutherford designed an experiment to understand the arrangement of electrons within an atom. In this experiment, fast moving alpha particles were made to fall on a thin layer of gold foil. Now, does anyone have this question, why gold foil only? I have this question, why only gold foil,
Because
not any other metal
he
foil?
need a thin layer, ma'am.
So gold
As
is one of
possible.
the, yes, exactly. Gold is one of the rarest metals which, on no matter how thin you convert it to, how thin sheet you make out of it, it will not break. It will remain continuous. That is why most intricate jewelry is also made out of gold. So gold metal is very ductile. It can be easily converted to sheets. So he chose a layer of a very thin layer of gold foil, and that layer contained it was only 1,000 atoms thick. Understand this. The layer, the thickness of that gold foil was only about 1,000 atoms. And when I am saying only 1,000, understand how many atoms are actually present in a single layer of other metals. Only 1,000 atoms of gold foil generated an extremely thin foil. Why we needed a thin foil was to understand that the alpha particles are crossing only 1 or 2 or 3 atoms at a time because of that thinness, right? So what he expected was, it was expected that the alpha particles would be deflected by the subatomic particles of the gold foil, as the alpha rays are doubly charged helium ions with a mass of 4 units moving with high energy. Like I said, he expected, as Thomson had said, that the proton is equally distributed among inside the atom. So Rutherford also expected that the alpha particles will go and touch the and collide with the proton and they will bounce back. Most of the particles will bounce back. Only those particles that will hit the electron will pass through the atom. Otherwise, all the particles will bounce back. But what happened was very, very interesting. Rutherford gave a statement about this, about his observations of this experiment. What he said was, it was like a bullet bouncing back from a tissue paper. You are hitting a bullet at a tissue paper and it is touching the tissue paper and coming back to your head and hitting you. So, this was how unexpected the results were for him. He thought that he had expected that the particles would simply bounce, all the particles will bounce back. But what actually happened was most of the alpha particles passed straight through the gold foil. Most of. Only one of 12,000 particles bounced back. So he realized that there is only one particle out of 12,000 alpha radiations is coming back to the original position. All are flowing through the atom, flowing through the sheet. And some of them were deflected by small angles. Now, also this was also observed that some particles, some alpha radiations were deflected, but by very small angles. That means they were passing through the atom, just that their direction was a slightly changed. That's all. These were the three observations. One is that the most alpha particles passed straight through the foil. Some of them were deflected by small angles, and only one of every 12,000 particles appeared to rebound. So, what he concluded out of this? What he concluded out of this was there is a positively charged center in there's a positively charged center in an atom called the nucleus that contains all the mass of the atom. So he said wherever the particle is colliding and it is coming back, that is where the entire mass of the atom is located. Otherwise, the entire atom is empty. He concluded that. Yes. I'm not able to hear someone is saying something. Is anyone's mic on? Please turn off your microphone, please. Yeah, am I audible now?
Yes, ma'am.
Okay, let's go ahead. So his first conclusion was that wherever the alpha particles are hitting the center, they are coming back. So he concluded that there is a nucleus in the center of the atom which contains all the mass of the atom. Rest of the atom is empty. Empty in the sense mass wise, because the mass of electrons is almost negligible. It is about 2000 times less than that of the proton. So it is almost negligible as compared to the protons. The electrons revolve around the nucleus in circular paths. This was also given by him that obviously they know that the atoms are spherical in shape. So he said that the electrons must be revolving around the nucleus under the effect of force of attraction between negative and positive charges. And again, when he said that only 1 out of 12,000 particles came back, he realized that the nucleus is extremely small. The part where most of the mass is centered is extremely small as compared to the entire atom. Correct? Now, what were the drawbacks? What were the negative aspects of his experiment? His experiment gave most important aspects of the structure of the atom, that the existence of nucleus, that there is something in the center of the atom that contains all the mass. But then there were some drawbacks that his experiment could not explain. You know of circular motion, uniform circular motion, correct? So what happens in a uniform circular motion is when the object is moving, it is changing its direction every moment, correct? That means it is experiencing some form of acceleration. Any body that is experiencing an acceleration radiates energy. So the drawback of his experiment was when he said the electrons revolve around the nucleus in circular paths. That means the electrons must radiate energy. Or he did not give that there will be a specific path. He said the nucleus, the electrons are revolving around the nucleus. So there might be a chance that the electrons may collide with each other and they radiate energy. They might move out of the atom, or when they lose the energy, they might fall into the nucleus also. All these questions were arisen through his experiment. So after that, there were, let's just go through the drawbacks. The drawbacks of Rutherford's atomic model were that the revolution of the electrons in circular orbits is not expected to be stable. He did not specify in what path they are moving, in what direction they are moving. He just said that the electrons are revolving around the nucleus. So, according to that statement, any particle in circular motion will undergo acceleration, during which the particle would radiate energy, leading to its instability. The particle will become unstable, it can move out of the atom, it can fall into the nucleus. Anything can happen to a particle which contains energy. To overcome these two aspects of the Rutherford's atomic model, who came across was Niels Bohr. Niels Bohr accepted that all the things that were given by Rutherford, that there is a nucleus, there are electrons revolving around the nucleus. What he did was he gave specific path. In that path only the electrons will be able to revolve. So the theory of electronic orbits was given by Niels Bohr, and he gave postulates. I hope you know what postulates are. Postulates are certain statements which are to be accepted without proof. He obviously gave his experiments also, he gave his conclusions, he gave how he came to these things, but we understand them as Niels Bohr's postulates. Okay. So he gave two things, that only special orbits. Now understand, if electrons are moving in very specific one direction, let's say left to right or right to left, whatever may be the direction, all electrons are moving in the same direction. So does this mean that there will be no collision between two electrons? Yes, because they are moving in separate orbits. These discrete orbits, discrete means separate from each other. They never cross paths. So when these discrete orbits are there in which the electrons are moving, then there is no scope of or electrons having energy, because the electrons are already revolving under the energy of force of attraction that is coming to them from the nucleus itself by the positive charge of the protons. So the electrons do not radiate any energy of their own, because they are moving in a circular path, in a very specific path, in a specific direction, without any collision among themselves. They do not radiate energy. So he called these orbits or shells energy levels, and he named them as KLMN or 1, 2, 3, 4. As you will go ahead, you will, if you opt for chemistry in your higher standards, you will understand how the electrons are arranged in these orbits, and these orbits also have subdivisions. Okay, so you will understand that in higher classes. So here is the conclusion of the session. Why you needed to understand these particular aspects was that the basic structure of an atom forms the basis of all the chemical compounds that exist in nature. Hence, it is important to understand the arrangement of atomic particles within an atom. Just because matter is made up of atom is not appropriate to understand why the arrangement of particles is important. In the next part, we will understand these things: electronic configuration, how electrons are arranged in these orbits, what is valency, what is atomic number and mass number, and finally isotopes and isobars. This we will be taking up in the next session. All right, so yeah, thank you. And now we will have 10 minutes of query session. If you have any questions, please let me know. Yes, anyone? Any questions? Any queries?
Ma'am, I have a doubt why Neil Wall have chosen the name KLMN, ma'am. Why not the other alphabets?
That's a good one, and I do not have the answer to that. But there are very specific reasons why they are given such names. It depends, and understand that.
Ma'am,
Am I audible now?
yes, ma'am.
Yeah, okay. There was some disconnection from my end. Okay, I'm sorry. Yeah, the
Ma'am,
question. Yeah,
can the shell's capacity be increased or not?
it can be increased depending on the number of electrons. It can be there are sub orbits in the atoms. We name them p, s, p, d. There are multiple configurative orbits that you will understand in higher standards. For the basics, this is what you have: four orbits, and in higher classes you will realize that these four orbits are also divided into suborbits. Any more questions?
No, ma'am.
Okay. Anyone else?
No, ma'am.
All right. Kavina, to answer your question, I think what can be concluded is there must be other alphabets being used in the similar field to indicate something else, to indicate some other aspects of atomic theory. Like atomic number is named Z, atomic mass or mass number is named A, capital A. So to maintain that consistency, the different letters are given to different shells. That is how we can understand this.
Yes, ma'am. Okay.
Okay, do we have any more queries?
No, ma'am.
I will be sharing a list of few questions in the group itself based on this topic, based on what we have covered today, and you will be answering in the group itself. Like in the morning session, in the morning we had a small session, question answer session. Similarly, on based on this particular topic, I'll be sharing a few questions. All right.
Okay, ma'am.
Okay, ma'am. Okay, ma'am.
Okay. Sir,
Yes,
sir,
madam.
are you there?
Yeah, I'm there.
Yes, sir. This is it for today's session. What
Okay.
should we do next?
Yeah. No, today it's over, no?
Yeah, the
It's
session for
whatever you
topic
wanted
for
to take.
today is over.
Okay. Now we'll close
Yeah.
it. We'll close it and then we'll continue the next class.
Okay.
Okay. Children, you have anything to say? How is the class? Rakshan?
It was very useful and it was nice.
Okay, Rakshan, what do you feel?
Very helpful. It's very useful, sir.
Aditi?
It's very helpful and easy to understand.
Yeah. So you raise questions in case you have any doubts. You can raise questions in the groups because all of you are in a different groups. So anyway, you raise questions. I will send it to madam. Okay. And she will be continuing almost every Friday. No, on this no, on science.
Okay, okay, sir.
Okay. Thank you, Thank you, madam. We will
All
continue in
right.
this
See
class.
you, see you, children. Bye bye.
Thank you, ma'am.
Okay, bye.
Thank you, ma'am. Thank you, sir.
Thank you.